All right. Algebra 2, Lecture 12.1 and 12.2, OAS A2, A24. The student will use the properties of exponents to simplify expressions. I'm going to run you through some of the properties of exponents that we learned back in Algebra 1 and show you how we're going to be kind of reviewing them today. Because you'll see them on the ACT, so you can't hurt to review them. Here we go. Here are some of the properties of exponents. When I was a kid, we called them the laws of exponents, but I guess they're just properties. So here we go. You may remember these. These are called the bases, and these are called the exponents. If you have the same base, x and x in this case, if you're multiplying like bases, is what we say, the same base, then you add the exponents. X to the n times x to the m is equal to x to the n plus m. And here's an example of what that might look like. X to the second times x to the seventh. You leave the base the same and add the exponents. Okay. Here we have x to the m divided by or over x to the n. You can think of all fraction bars as the words divided by. So if we're dividing like bases, you leave the base the same and subtract these exponents, top exponent minus bottom exponent. And here's an example of what that might look like. X to the seventh divided by x to the fifth, or x to the seventh over x to the fifth. Leave the base the same and subtract top exponent minus bottom exponent. And that would be 7 minus 5 is 2. Okay? Here's another one. We're raising a power to a power. X to the n to the m. When you do that, if you see n to the m, this is when you multiply exponents. A lot of kids get confused here and they want to multiply these because they see this is multiplied. When you multiply like bases, leave the base the same and add the exponents. When you're raising a power to a power, that is when you multiply your exponents. For instance, this is x to the second to the seventh. We're going to multiply these exponents. That will give me x to the 14th. So this should all ring a bell. We covered this in Algebra 1 a while back. Here's another one. X to the negative m can be written as 1 over x to the positive m. You'll see that a lot. So x to the negative 3, if they said rewrite this so that the exponent is positive, you would say that's 1 over x to the positive 3. Very simple stuff, that. You just got to remember. Here's another one you run into. You got a negative exponent in the bottom. Well, if you run into that, you just move it to the top of the fraction, and you can think of this as 1 times x to the negative m. So it leaves the 1, and x to the m goes to the top, and the exponent becomes positive, and x to the m over 1 is x to the m. So you could think of this as this or this. And an example of this you might run into, you might simplify your answer or wind up with this, and if your instructions say make sure that your exponents are positive, you say, okay, well this will move to the top of the fraction, making the exponent positive and leaving a 1 in the bottom, and x to the 8th over 1 is usually just written x to the 8th. Okay? And here's an example of a couple of things, a couple of exponents in them that are negative. If you have a negative exponent in the top and a negative exponent in the bottom, and you're asked to write them with positive exponents, you just move this one to the top, make the exponent positive, move this one to the bottom and make the exponent positive. That's the mechanics of what you're doing there. And this is what it might look like. I want to make my exponents positive, so to make this positive, I'll put it in the bottom. This one jumps up top, and they're positive. Whoops, that's supposed to be a 3. Don't change the value of your exponent there. It's a negative 3, it should be a 3. So those are the properties, some of the properties of exponents, and we're going to run into combinations of these throughout the course of what we're doing. So let's just jump in and see what it might look like. Simplify, your answers must contain only positive exponents. Here's how I would do it. If I were me, I would look at this and I would say, okay, I'm trying to simplify this. I've got 3 times v times u times v. These are like bases. This is an implied 1. So first thing I'm going to do is say, if I've got like bases, I'm going to leave the base the same and add my exponents. So I'm going to say, well, this is 3v. I'm adding 1 plus negative 2. 1 plus negative 2 times u. I left the base the same and added the exponents. Well, that's 3 times v to the 1 plus negative 2 is negative 1. I just simplified that. Now it says I want to make sure my answers contain only positive exponents. So I'm going to change v to the negative 1 to 1 over v to the positive 1. I'm going to put a 1 over it and the exponent becomes positive. That's the mechanics of what we're doing. Here's an example. So that's what I'm going to do right here. I'm going to call this 3 times 1 over v to the 1 power, and you don't have to show the 1. If it's the first power, it's implied, times u. And we can think of this as 3 times 1 times u in the top of the fraction. You can think of 3 as being 3 over 1 times 1 over v, that's this, times u over 1. You don't have to show this part, but here's why you can just put the 3 and the u in the top of the fraction, because 3 times 1 times u is 3u, and 1 times v is v. So, in other words, you can put a bar here and drop the v down and leave the 3 and the u in the top of the fraction. Alrighty, let's take a look at another one. I've got 3 times a times b squared times a cubed times b to the negative 4. Remember, there's an implied first power here. So I'm just going to go through and do this the way I would. I would say, well, a to the first power times a to the third power. I'm going to leave the base the same and add my exponents. That's the first property of exponents we talked about. If the bases are the same, leave the base the same, add the exponents. And I'm going to look at this, I'm going to do the same thing. I've got b to the second times b to the negative 4. I'm going to leave the base the same and add these exponents. 2 plus negative 4 is negative 2. Then I'm going to move this one to, I'm going to think of this as over 1 because I'm going to move this to the bottom of the fraction. That's the fast way of what we did over here on the left. This just moves to the bottom of the fraction and the exponent becomes positive, which is one of those properties. There we go. This moves to the bottom and becomes positive. If it's negative in the bottom, it moves to the top and becomes positive. This negative exponent becomes positive in the denominator. You can think of this as over 1. So that's what I employed there. And it's basically the same thing I did here. I just showed the steps of why that would be true. But you can't just think of it as over 1 and drop it down into the bottom. There we go. Let's see if I got those two right. Number 1. Whoops, I grabbed the wrong key. Number 1 is 3u over v, yay. And number 2 is 3a to the 4th over b squared, yay. So we're off to the races. Let's take a look at another one. I'm going to do just what I did before. I'm going to go through and multiply everything, and then if I have any negative exponents, I'm going to drop them down into the bottom of the fraction. Here we go. This is 4 times 3. Those are, I'm just going to get 12. They're not exponents. They're coefficients, so 4 times 3 is 12. This is u to the negative 1 times u to the 4, so I'm going to leave the base the same and add these. The exponents are being added and I'll get positive 3. Now I'm going to multiply v to the negative 4th times v to the 1. There's an implied 1 there. That will give me v to the negative 3. Okay, so I've multiplied my coefficients. I multiplied u's and I left the base the same and added my exponents and got 3. Here I was multiplying v's and I left the base the same and added these exponents and got negative 3. Now I'm going to think of this as being over 1 and drop this one down because my instructions say leave your exponents positive. Write your exponents in positive form. So this answer is correct. But the instructions say your answers must contain only positive exponents. So in order to do that, I just said, well, this could be thought of as this over 1. Drop this down here, and the exponent becomes positive by the properties of exponents we talked about up above. We covered them in more detail in Algebra 1. Well, let's see if I got that right. 12u cubed over v cubed. Yay! Just a little review, stuff you'll see on the worksheet. Here we go. I'm going to multiply like bases. I'll say, well, I got y to the first times y to the first. That's an implied 1 there. If you don't see the exponent, it's an implied 1. Y to the first times y to the first, leave the base the same, add the exponents. Y times y is y squared. That makes sense. Here I'm going to have x to the second times x to the third. We leave the base the same and add the exponents. Negative 2 plus 3 is 1. Traditionally, I like to write my answers in alphabetical order. I would call it x to the first power times y squared. They're both positive. That's an implied 1 right there. I'm not showing it, but it's there. It's implied. And that's how I would leave my answer. That's what I would expect to see on a multiple choice situation. That's what I would be looking for. But it could be written like this. It's just more traditional to put it in alphabetical order, x, y. You don't have to, though. Let's take a look at what the answer key says. It says y squared x. It leaves off the one exponent. It writes it like this. But as I said, you don't have to write it in alphabetical order. It said, well, x to the 1 is x. The implied exponent. So these two mean the same thing. Alrighty, so there we are. Messing around with a review of exponents. And the worksheet should be very similar to what we've just shown you with these 4 examples. You can do this. Properties of exponents.